My name is Joshua Odemark. I'm the CTO and founder of Pandio. I'm here today with Philomena Lamoureux. She's head of AI at Blooma.ai. Thank you so much for joining us. Can you just give us a brief intro about yourself and Blooma.ai?
Yes, of course. So I got my PhD in computational nanotechnology and material science, and then worked as a researcher at Stanford, where I developed machine learning methods to accelerate materials discovery using quantum mechanical simulations. So combining quantum mechanical simulations with machine learning to sort of really help discover new materials. And now I work at Blooma, where I developed the AI platform that powers our services. And we do automate loan origination in the commercial real estate space.
Oh, it's amazing. What kinds of AI and ML are you working on at Blooma?
We use all sorts of AI. We use natural language processing, we use computer vision, and also predictive modeling. I think the largest part really is natural language processing. So we do have automated document parsing, we bring named entities, we do text classification, document classification, table parsing, but we also work with pictures and predictive modeling. And we have a large number of machine learning models in production. And we also work with privacy preserving machine learning solutions.
That's amazing. So can you give us a use case where, is that like unstructured documents type thing? So you're trying to parse like a PDF or something like that?
That's exactly right. Yes. So one example is a marketing brochure that people who apply for a loan would provide the lender to sort of advertise the property they want the loan for. And they put all sorts of information in it and all sorts of pictures. And our job is to sort of filter out the relevant stuff, because there's a lot of fluff and, just marketing content. So we use, for example, named entity recognition to parse out how much the borrower wants the loan to be, and also, parse out pictures that feature the property itself, and things like that.
Nice. That's fascinating. That's an incredibly tough thing to do. Can you step back for us a little bit? And so what is the value prop of Blooma? Who do they help, and what's their sort of business?
The business is really to help bankers and investors to make faster and better decisions on loans in the commercial real estate space. So commercial real estate means someone applies to get a loan to buy a property that can be used for a commercial purpose, such as a shopping center or a medical office even. So different kinds of commercial properties. And these deals are, typically a little bit larger than the ones you would have for typical mortgages, so for private use. And they involve also more documentation. So the property itself really is featured more because it is a revenue generating entity, right? So people will look at how much revenue this property can generate, how that compares to other properties that are similar, and how the area is for the purpose of the property. For example, if you have a shopping mall, you want to have people living close by that have, the kind of salary and demographics that actually would support a shopping mall like that.
That's cool. And so in sort of your day-to-day, what type of tools or what's your go-to, or the things that you're using a lot as far as like software, libraries? What types of things are you using every day?
So we use Python, and we develop machine learning models, including deep learning models. I typically do a lot of model chaining as well. We also use OCR, so optical character recognition. I can't go too much into the details, but that's basically on a high level what we use.
Awesome. Well, that's fascinating. So I see, federated learning. So that's very interesting. So I understand you have some experience in that. So that's sort of a topic that's near and dear to my heart as well. So can you give us a sort of sense of where you've used that and what your opinion of it is?
Yeah, of course. So federated learning is commonly used in industries which deal with private and distributed data. And this data can be private either because it contains sensitive information or because the data is owned by a company or a person, and there's a competitive advantage associated with that data. So in this case, sharing the data is disadvantageous and refer to the data as proprietary. So in both cases, industries who deal with either form of private data that is distributed over several silos, this can be hospital databases or industrial Internet of Things, these industries use federated learning to leverage the power of the data while ensuring that the data is local and private, and the individual data samples aren't breached. So just whenever you have privacy concerns and distributed data in combination, federated learning can be one of the top options. But there are also other options to, do privacy preserving AI.
That's interesting. So if you're going to do something like federated learning, what are some major obstacles that one might run into using something like that?
Mm-hmm. There are several obstacles. For example, you're training a central model, and there's the assumption that the different silos sort of have a more homogeneous data distribution. And if, that isn't the case, you sort of have to think about how you aggregate the results. So for example, if you have 3 customers and they have data, you send off to your models, the models learn. Is the final model really going to work for all 3 customers in the same way or not, right? This is a very important question, because if the data is really different across the different customers, it's actually better to train a model for each customer individually. And that's something, if you can't see the data at all, it's something that, is not super straightforward to understand. So you have to really do both, compare the individual model performances, but then also aggregate it, and it's sort of an additional overhead that you have to go through. Another thing is sort of the trade-off between accuracy and privacy. So differential privacy is used in federated learning to prevent, data leakage through the model parameters. And there can be, a pretty significant trade-off if you really want your data to be fully protected and everything to be fully private. This might really impact your model accuracy in the end. And then lastly, if you say use federated learning for Internet of Things or industrial Internet of Things, there's a lot of broadcast overhead. So that communication, say if you have millions of users and you train the models on their devices, that can, be a pretty big challenge in terms of architecture and broadcasting.
Yeah, that's interesting. So you mentioned something that some people may not be familiar with. So differential privacy. Can you talk a little bit about what that sort of looks like and how you sort of add noise to data to keep things separated?
Basically, each time when you have your parameter updates, you will usually add regularization and then also add a noise. And that noise can come from a certain distribution, but it has to sort of really affect the parameter updates in a way that, you can't infer whether a certain, data point has been part of the data sample or not. So for example, you have a hospital and there are samples of patients, maybe lung scans, and you sort of want to have the same result whether one particular sample was in there or not, because otherwise you could infer that that sample was part of the database, right? So this way you could sort of hack information out of the model by just doing trial and error, or for example, in cases where you have word prediction in keyboards, you can type my social security number is, and if the differential privacy hasn't been done in federated learning, it will still give you some sort of number, which could be part of like a text that it has been trained on, because certain, neural networks really memorize details. So this is really something where you have to make sure that your model is private enough, and there are ways to sort of try to test that, and there are like companies who will test this for you as well.
Nice. Yeah, that's always was a really fascinating sort of area for me. That's because that's a very difficult problem, and one thing that's been interesting for me too is like, have you messed around at all with like doing machine learning with encrypted data? So like homomorphic encryption and things like that?
Yes, we actually have a solution where we use encrypted data. I can't talk too much about it. Homomorphic encryption is really generally a field that is moving pretty fast. And I think there has been work published where they could even approximate nonlinear functions now, which is sort of what we really need for deep learning. So we are all really looking very interested towards the new solutions that are coming out every day there.
That's awesome. So to step back to federated learning. So what's like an actual real world use case you've seen where some company has sort of executed on that very well with great results?
Yeah. So I think the medical industry is one of the prime examples. So for example, major companies, including Novartis and Merck, They are building a shared drug discovery platform. They call it Melody with 2L and 2D. And they use this platform to leverage federated learning to train data sets on all the data that they have, but without sharing their proprietary data. Another big use case, as I mentioned before, actually is industrial Internet of Things. So in Industry 4.0, this is actually really used a lot. And here you have smart machines and smart factories that use machine learning and deep learning models for intelligence, inference, and predictions. But again, here you still have to, care for data privacy, and you actually don't want to send the data to the cloud or end devices. So they remain with the machines, but the model parameters are shared. As I mentioned before, companies like Apple and Google have very successfully used federated learning as well. So the auto completion that you have on your iPhone, be it iPhone or actually Android, it doesn't really matter. Depends on the keyboard you use though. But if you have the next word prediction, that's actually also trained based on federated learning. And that's sort of one of the use cases where what I mentioned before becomes important, where you have so many different devices these models are trained on. This overhead, has become really important. And then you sort of have to really synchronize when the models send the updates back, because you don't want to, slow down the devices. So this is really an interesting architectural problem, but they've done a great job. So auto completion, next time you Google, that's all based on AI.
Yeah, that's fascinating. And Google, they open sourced part of what they use to sort of do that with Androids. That's fascinating. There's tutorials and stuff that people can go check out and make it. I mean, it would be terrible to say federated learning is simple because it's a very complicated concept, but they do a pretty good job at breaking it down. For some of our younger viewers of these podcasts, could you talk about kind of how you came to be sort of head of AI? So what did your career path sort of look like? What skills do you feel were really important for you to sort of achieve the success that you've achieved?
I think first of all, technical excellence is very important. If you really want to be in a leadership position, getting a PhD is definitely a good move. It definitely won't hurt. And I think especially if you're young, you might as well just get it out of the way than having to go back later to school. Besides that, starting to, train your leadership skills early. So if you have the opportunity to supervise someone, trying to get that done so you have that experience as well, because obviously you are going to be supervising projects and or teams. So this is very important as well. And then a business focus is also important. That means understanding what your company is really providing and see how the AI that you're building is really directly related to your product. I think people who come out of college will lack that and will have a more academically and mathematically focused skill set, which is great. It's the foundation. But that customer focus and the product focus is something that at some point you should probably build on top.
That's amazing. So let's talk a bit about cybersecurity. So why do you think it's so relevant today?
I think it's absolutely relevant and we see it in the news every day. But it's really because it protects all categories of data from theft and damage. This includes sensitive data, personally identifiable data, so PII, health information, personal information, intellectual property as well, data and governmental and industry information systems. So not only data, but really sort of data that is more sort of embedded in systems as well. And access to that data can really have immense consequences. So the stakes are really high. Just case in point, in 2018, the city of Atlanta was attacked by the SamSam ransomware, and the attackers asked for, I think, $51,000, which, comparatively is not too much, but the ransomware was so harmful that the city was really offline for, I think, 5 days. And this caused several significant citywide operations to be halted. And it ended up having a recovery cost of 17 million. So that's a very large number, and then you have the individual stakes as well. So not only financially, but say if your social security number is breached, there's fraud. This can really have very damaging effects on your reputation, on your financial background. So this is why it is really so harmful to individuals, but also to governments and companies at a larger scale.
Yeah, thank you for that. And so if we tie this to sort of federated learning, so something that's interesting. So you mentioned like the phone example. So as you type on your phone, it starts to learn your acronyms and, you know, the lingos, the names, and then it sort of feeds back to a central model that seeds new devices and things like that. And then your other use case of, you know, sort of training a model at 3 different providers to have sort of a single model or individual models. So how do you sort of ensure that that's not a sort of another angle or risk for cybersecurity?
Yeah, I mean, the way you would work it out is probably take aggregations even of different customers' vocabularies and, you know, use only the words that all of them use. And this way you could sort of filter out very individual words. You can also have models that are just customer specific, as I mentioned before. So you have maybe one model that is sort of more generic and everyone uses it, but then you have your own model on your own device and that'll aid the prediction or really just do the whole prediction for you. And then it will use the words that you always use. So I think it's a really sensitive topic. And, you know, if you have sort of access to the source code of like this local model, say if you train it locally and then only use it locally, that can contain a lot of important information. So yeah, using differential privacy or other methods where you don't even have a centralized location can really be beneficial. And, you know, you have to look into that and really make sure that your model doesn't leak anything.
Awesome. And so if you were to sort of try to imagine out into the future, what do you think federated learning is going to sort of grow and get more people sort of using it? Because I guess from my perspective, one of the big hurdles is sort of access to data. Is there's a lot of companies, Facebook versus Google and things like that, they're not going to sort of share a lot of data and things like that. Same with like healthcare providers and things like that. And so federated learning is one of those things that helps you pass that huge hurdle. So if you were to sort of, is this going to be something that's going to help bridge that gap, or is there maybe something else that's going to help companies share data more prolifically?
Yeah, absolutely. I totally agree with you. You know, data is not very democratized, and some of it maybe shouldn't because it's private. So I totally agree with that. And there are like really a lot of levels to this questions, really. The first aspect being, you know, regulations that are catching up with the technology. So we have GDPR, which is one of the first laws implemented, but then we also have similar laws now in Canada, California, and Brazil that are active at this moment as we speak, right? And these laws now, they will foster the use of privacy-preserving machine learning methods because at this point, a certain kind of data, it's just the only way that you can really learn from it because it's just not, you know, you can't just share it legally. And then another aspect would be like market size. So federated learning is projected to become a $200 million market by 2028. So I agree with that. Companies will probably seize the opportunity to use more federated learning to capitalize on the data resources that they have without sharing the data, keeping their competitive advantage. But then I also think that technologically, the field of privacy preserving AI is developing very rapidly. And new approaches, such as the aforementioned swarm learning, are being developed every day. So swarm learning doesn't really use a centralized location. So the models sort of are shared between the different silos, and they also use a blockchain to keep things secure. It's a very neat algorithm. I'd love to share the link with you if you're interested in that. And I think these technologies are gonna, you know, yield better trade-offs between accuracy and privacy, and maybe also are able to, you know, be trained faster. So I think that will really push the field forward. So I think federated learning in itself is a method that we'll use now and also in the future. But I think at some point, and maybe I'm optimistic on this one, I think there are going to be even better technologies. This field is just really fastly developing. And then finally, and this is true for all sort of decentralized machine learning methods, they all rely on a certain communication bandwidth. And this is, again, especially important for edge applications. And so while we can use 5G now with the phones, that is going to enable a lot of more communication, so better, faster distributed learning, but not every edge application lends itself to use 5G, right? So that means that improvements in broadcasting and device communication will also really push the field forward in the future. And I think that's also really something where people are trying to develop new technologies. So I think overall, yes, the whole field of privacy preserving AI is going to grow a lot. I think at some point, if the tools are easy to use, it's probably going to even become one of the major ways to do it, because, if it's the same effort, why not use a model that, uses encrypted data and so on. It's just better and more secure for companies. So I really think that this is a great field to look into, and it's really sort of the future of AI, I think.
Amazing. You made a lot of great points there. Thank you for that. So we just have a few minutes left here, and something that I've been very curious about is, me, myself, I'm very passionate about sort of the general adoption of AI and ML, helping anybody sort of use more AI and ML at their company, regardless of the size. And so in that vein, one of the hurdles that we see with a lot of people that we talk to ourselves is the side of like the ROI of an AI or ML project, understanding what are we going to get out of this and how do we measure the success of it. You've been involved in a lot of projects at your current employer, and if you have so many models in production, I have to imagine you've got maybe a few tidbits that you could share to help people, maybe if they're wanting to pitch a project to management or try something. What would you say to those people to help them sort of understand how to pitch their next AI or ML thing to start working on it?
Yeah, I think that's a really good question. And I think I would like to answer that by just making the assumption, or just saying that AI projects are pretty expensive. So you need the time of the salaried people who work on developing the AI, and they're pretty expensive. Market salaries are pretty high. Then you have the data, and you have to manage the data, maintenance the data, maybe in a warehouse. That also takes a lot of resources. So, but then on the other hand, it's sort of hard to predict whether your problem is going to be, solved in an accurate enough way for it to be relevant. So doing a lot of research up front and really trying to estimate, okay, if I develop a model now with the data that I have, or the data that I can get, like what is the industry standard of models that do this? For example, for named entity recognition, you would have so-called F1 scores, similar to accuracy of 95%, right? So if that is not sufficient for the application that you need, okay, even if I do industry standard, the best models that are out there, it's not going to be sufficient. But if 80% will cut it, then you can make an estimate that way. So because of the high cost, I think everyone who would be willing to internally invest in a project like this wants to see low risk. And that means, that you really think the accuracy can be achieved. And then also, that you have a pretty specific implementation plan. So you build a POC. If the POC doesn't work, maybe they can draw back. Right? So you have a step-by-step milestone plan, and that'll make it, more achievable and more sort of like a step-by-step process. So, that executives can be like, okay, if milestone 1 isn't reached by then, we can pull out of this project to cut our losses. And I think if you see it from that perspective, that'll help you to really pitch your project in a way that is appealing to those who make the decisions to fund your project in the end.
Well, that's amazing. Thank you so much for that. And that wraps up our sort of podcast for today. I want to thank you so much for sharing your expertise with us. It's been incredibly rich 25 minutes here, so I really appreciate that.
I appreciate
Yeah, thank you.